Welcome to Math with Professor V. This is video lecture for section 1.1 of business calculus, sometimes called brief calculus. And in this lesson, we're going to go over slopes and equations of lines. So hopefully this is a review. If you need more in-depth lectures on graphing lines, then head over to the Intermediate Algebra Video Lectures playlist. I'll also link it in the description, just in case you need a little bit more of a refresher. Okay, so first we're going to define what the slope of a line is. In everyday terms, I would refer to the slope of a line as the steepness of a line. So mathematically, we say the slope between 2 points, x1, y1, and x2, y2 is given by the following. We refer to the slope of a line as m, and it's equal to this little triangle up here, that's delta, that means change. Change in y over change in x. How do we find the change in y? We subtract the y coordinates. The change in x, we subtract the x coordinates. And often this is referred to as rise over run, because change in y tells you how much your line is rising or falling if it's negative, and run tells you how much it's changing in the horizontal direction, in the x direction. So here we're just dealing with the xy plane. Let's label our axes. And if you have a line, okay, who knows? This one's going to have a positive slope because it's increasing. If you were to walk on it from left to right, you're going uphill. And this x1, y1 is a point on the line. I'll say it's right here. And then x2, y2 is some other point on the line. So you can calculate or compute the slope of a line using any 2 points that your heart desires on the line, okay? Now, the slope of a horizontal line is 0, flat, like this, okay? Just think when you hop on the treadmill and you put the incline on 0, that means, yep, flat. You're not going uphill, you're not going downhill. The slope of a vertical line is undefined. Vertical line looks like this, okay? And if you forget, you can still refer to this definition right here, that m is change in y over change in x. If the change in y is 0, like it is here with the horizontal line, you'd have 0 over a number, which gives you 0. In the case of a vertical line, the denominator is going to be 0. Notice how the x's are not changing if you picked 2 points on the line. And so you'd have some number over 0, which is undefined. Okay, so if you forget which is which, you can always just refer back to your slope formula. Okay, now that we have the formula for slope of a line, we can put it together and get the equation of the line. So if a line has slope m and y-intercept b, then the equation of the line, whoop, there's a little e we need, okay. In slope-intercept form is y equals mx plus b. You've probably heard this before in some algebra class back in the day. Now, if a line has slope m and it passes through the point x1, y1, then the point slope form of the line is given by y minus y1 equals m times x minus x1. So we have two different forms here for writing the equation of a line, and I want to point out what the difference is. First of all, slope-intercept form requires the slope, obviously, and then the y-intercept, b. Since it's the y-intercept, that's where the line crosses the y-axis, so the x-coordinate is 0. So if I were to graph that for you, what it would look like is, I don't know if m is positive or negative, it's all good. Let me graph this line, boom. And b is right here, where it crosses the y-axis. So when you're working with slope-intercept form, you need the slope, and then you need specifically the y-intercept. The other form, point-slope form, is a little more versatile because you don't necessarily need the y-intercept b. You can just have any old point on the line. That's what x1, y1 refers to. It could be the y-intercept, or it could be any other point on the line, and you put it together and you have point-slope form. And also point-slope form should look a little familiar because if you'll allow me. We have y minus y1 equals m times x minus x1. If I divide by x minus x1, then you have y minus y1 over x minus x1 equals m, which is basically how we compute slope. It's just these two are not fixed values anymore. Okay, so when to use each one, usually the directions will tell you. However, if they don't, let me just point out some differences. When you're working with slope-intercept form, this one is usually the easiest to graph with, okay? And then point-slope form, I usually use if I'm asked to write an equation. I'm gonna abbreviate equation, EQN, okay? So if in the directions you said, find the equation of the line, I usually go straight for point-slope form. And then in other scenarios, you might have to finish up and put everything in slope-intercept form for your final answer. So this is more like an intermediary step, okay? Let's practice some examples and you'll see. So first one, find an equation in slope-intercept form. Okay, so that means they want y equals mx plus b as our final answer for all of these, for each line. So it says the line goes through the point 2, 4, and the slope is -1. So for all of these, we're gonna start with point slope form and then clean it up so that we end up in slope-intercept form. So here we go. 2, 4, that is my x1, y1, right here. x1, y1. I would label it so you don't get all jumbled up. Let's write the point slope form formula one more time. Y minus y1 equals m times x minus x1. And then now substitute in y1 and x1. The x and y with no subscripts stay x and y. Don't plug in numbers there, okay? So we're gonna have y minus 4 equals, did you see what m was? It's -1, very good. -1 times x minus 2. How are we doing? Good. Now let me just distribute this -1. I have y minus 4 equals -x plus 2. And then remember my goal, I have to end up in y equals mx plus b form, which means y needs to be isolated all by its lonesome on the left-hand side. Is that currently happening here? Why, no, it is not. So we need to get rid of that 4. 4, get out of here. I'm going to add 4 to both sides. And then now I'm left with y equals -x plus 6. Okay, I just want to point something out. So since it's in point slope form now, again, I can see, all right, m is -1. Can you tell me what b is? B is 6. So that means the y-intercept is at 0, 6. Okay, so when you have the equation of a line in slope-intercept form, you get a lot of information out of it. Okay, very good. Let's look at another example. Again, the directions are the same. Find the equation of the line. This time it says that goes through 8, -1, and 4, 3. Okay, look at this versus the previous one we just did. If you're ever confused on how to start a problem, look at one that you solved successfully and say, okay, how can I build off of that? So in the last one, yes, they gave us a point. They gave us not only 1 point, I got 2, so I'm good there. And they gave me the slope. Oh, they did not give me the slope, but that's fine. We have a formula. I can go ahead and compute the slope. Again, I'm going to tell you, let's label these though, just so you don't get jumbled up when you're plugging everything into the slope formula, because that's the most common place that students make mistakes. Not that they forget the formula, they just plug it in the wrong spot and then the sign comes out wrong. It's very tragic. Okay, so slope is y2 minus y1 over x2 minus x1. And it doesn't matter which one you called x1, y1, x2, y2, just be consistent throughout the problem. Okay, so y2 minus y1, that's going to be 3 minus -1 over x2 minus x1 is 4 minus 8. So in the numerator, I end up with 3 plus 1, that's 4. divided by negative 4, so this is negative 1. The slope is negative 1 again. What in the world? Okay, then we're going to go ahead and yes, go back to point slope form. Y minus y1 equals m times x minus x1. I already know m is negative 1. And then x1, y1, right now I have it labeled as 8, negative 1. You could alternatively use the other point 4, 3. This could be x2, y2. It doesn't matter. It just has to be an ordered pair, an x and a y that go together. Okay? Do you like one of these any better than the other? I'm just going to stick with 8, negative 1 for now. So y minus y1 is negative 1 equals m is negative 1 times x minus 8. So what is this? Y plus 1. I'm going to distribute, negative x plus 8. Subtract that 1, so y equals negative x plus 7. Okay, now if you were concerned and you would have rather used 4, 3, have no fear. You would have gotten the same answer. So let's just confirm it for you guys, just this one. So we have y minus 3 equals negative 1 times x minus 4. The m doesn't change, right? Just the points. So y minus 3 is negative x plus 4. How do I get rid of the 3? I add it. So y equals negative x plus 7. Oh me, oh my. They match, of course. So just... hopefully now you believe me in your heart of hearts. You can choose either point when substituting in for point slope form. Use the one that will be the least troublesome, okay? Let's see, this one's so similar, but it's got a little twist to it. So here we go. The point that goes through 8, negative 1 and 4, negative 1. So let's start it off the same way we did the other one. I need to find the slope. So that's x1, y1, x2, y2. So m is y2 minus y1 over x2 minus x1. So that's negative 1 minus negative 1 over 4 minus 8. So what's that going to be? Negative 1 plus 1, that's 0 over negative 4. 0 divided by negative 4 is 0. If the slope is 0, what is going on? Do you remember? It means we have a horizontal line. Okay, now there's a shortcut to getting the equation of the line, but I'm going to go through the long process and then we'll talk about the shortcut in a second. So here's the slope. Let's do point slope form. So y minus y1 equals m times x minus x1. I'll just use the point 8, negative 1. Let's go. So y minus negative 1 equals 0 times x minus 8. This is y plus 1 equals 0 times whatever is going to just give me 0. So I end up with y equals negative 1. Okay, I told you there was a shortcut, right? Your ears perked up. Everyone loves a good shortcut. Y-axis, x-axis. I'm going to plot the 2 points that they gave us, okay? If you'll allow me. So here, 1, 2, 3, 4, 5, 6, 7, 8, negative 1. Okay, and the points are 8, negative 1, 4, negative 1. Boom. It should be a wee bit lower. Hold on. Is that better? Okay, good. We love it. Just make the dots a little bigger if it doesn't go through perfectly. So notice here, yes, I can tell I have a horizontal line. Slope is 0. How can you just jump to y equals negative 1? Well, look at this line. Every single point on it has y coordinate negative 1. Like this point right here, that's 0, negative 1. This point right here, that's 10, negative 1. Any point you pick has y coordinate negative 1. And x can be anything. X is just running wild. So that's why the equation doesn't involve x. See how x is just roaming free? The only requirement to be on the line is that your y coordinate has to be negative 1. Okay, so that's basically the shortcut. As soon as you notice you have a horizontal line, whatever the y values are, see, negative 1, that's the equation. So I'll write the rule for the shortcut for you, should you care to use it in the future. So horizontal line has the equation y equals k, right? Whatever number you have. In this case, k was -1. And then similarly, a vertical line, it's up and down, right? In a vertical line, which coordinate's running wild? The y coordinate can be anything, only x is fixed. So vertical line has the equation x equals k. Okay, very good. And then an alternate form of the equation of a line is ax plus by equals c. This is often referred to as standard form. Okay, good. Often we require a, b, and c to be integers, and usually a is positive, but I don't think we're going to get into that too much. All right, very good. Moving on, parallel and perpendicular lines. So we say that two lines are parallel if and only if they have the same slope or if they're both vertical, right? Remember, if a line is vertical, its slope is undefined. So if you have two vertical lines, they're going to be parallel. Two lines are perpendicular if and only if the product of their slopes is -1. I'll explain what that definition means in just a minute. Or if one is vertical and the other is horizontal. So when you say the product of their slopes is -1, that's the same as saying the slopes are opposite reciprocals. You're like, that doesn't help. Okay, let me give you an example. If I know the slope of one line is 2/3, the slope of the line perpendicular to it, and this little upside down t means perpendicular, would be -3/2. So let's introduce this abbreviation, perpendicular upside down t. Parallel, you've probably seen we put like two little parallel dash lines. Now, look at these slopes. I told you this would mean these two lines are perpendicular. If I multiplied 2/3 and -3/2, what do you get? Just cancel, 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 cancel. You just have that negative left, so this is -1. So that's what it means. The product of their slopes is -1. That's just like a more condensed way of saying the slopes are opposite reciprocals. So depending on the book, they'll give you either definition. Okay? So here we go. Let's practice finding equations of lines using this new criteria about parallel and perpendicular. Find an equation of the line that passes through 2, -5 and is parallel to 2x minus y equals -4. So when I write the equation of a line, remember, we're going to use point slope form. Yes, yes. Okay, I need two things. I need a point, and I need a slope, and I need a point. I need a slope and a point. They gave me the point, 2, -5. That's my x1, y1. Okay. What I need to do is go ahead and find the slope. Well, how can I do that? They told me my line is parallel to this line right here, 2x minus y equals -4. So can you tell me just by looking right now what the slope of that line is? Probably not. We need to put it in y equals mx plus b form in order to see what the slope is. So we have 2x minus y equals -4. I want to get y all by itself. My goal is to put it in y equals mx plus b form because then I can see the slope. So let's move the 2x over to the other side. So -y equals -2x minus 4. And then, yes, get rid of that negative. So dividing everybody by -1, which is the same as multiplying everybody by -1, doesn't matter. Can you tell me now what the slope of this line is? I hope so. M is 2, yes? Woohoo! Yeah, you know, had we looked at the original, we would have guessed that as well, but that's not always the case. So please don't live dangerously. Take the step to rearrange it. Okay, now we're ready to go to point slope form. M is 2. So we have y minus, what was y1? -5 equals 2 times x minus 2. And then just clean up y plus 5 equals 2x minus 4. Subtract 5, so y equals 2x minus 9. And we're done. How was that one? You're okay? All right, let's take up the spice level a notch. Find an equation of the line that passes through -2, 6 and is perpendicular to 2x minus 3y equals 5. So again, we're going to use point slope form to write the equation of the line. They gave me the point, so I have x1, y1. Yeah, here's my x1, here's my y1. I need m. How do I get m? They told me this time it's perpendicular to this line. So let's figure out what the slope of this line is first. So 2x minus 3y equals 5. How do I get the slope of this line? I get y by itself. So let's subtract that 2x over. -3y equals -2x plus 5. And then yes, divide everybody by -3. Please do so carefully. So y equals, this is going to be positive 2/3 x minus 5/3. How you doing? Okay, this -5/3 has absolutely no relevance in this problem. Just focus your eyes on the slope of the line, 2/3. So the slope of this line that was given to me is 2/3. This time though, my line is not parallel, so it will not have the same slope as this line. My line is perpendicular. So the slope of my line, which is perpendicular, would be -3/2. Very good. So that's what we're going to substitute in for m right here in point slope form. So let's hop to it. Y minus 6 equals -3/2 times x minus -2. I'm just going to write x plus 2, okay? Good. And then this is going to be y minus 6 equals, let's distribute, -3/2 x minus 3. Good? Last thing, add 6 to both sides. And we have y equals -3/2 x plus 3. Beautiful. Good job. Okay, only thing left to do is graph these lines, which we're so adept at finding equations of. So keep in mind when you're graphing a line, you only need 2 points. If you want more, because you're a little paranoid or nervous and you want to make sure everything's lining up, go for it, but 2 is enough. So let's graph the following lines. So we have y equals 4x plus 5. And earlier I told you y equals mx plus b is like the easiest way, the easiest form of the equation of a line to graph with, usually. So here I can tell the slope is 4. I want you to think of it, though, as 4 over 1. That way it's easier in your mind to think rise over run is 4 over 1. And then b is 5, which tells me the y-intercept is at 0, 5. So that's actually what you start with first. Plot the y-intercept. Let me label my axes, x, y, 0, 5, 1, 2, 3, 4, 5. Okay, that's 1 point. And then to get the second point, I'm going to use the slope and count. So we're going to go up 4 and run 1. Since they're both positive, you go up and to the right. So from this point, I'm going to rise 4, 1, 2, 3, 4, and then run 1. So that's where I'm going to plot my second point. Right there. Good? Then connect them. And then the other very important thing is that you put arrows on the end of your line because it extends forever. Later on, you might have scenarios where there aren't arrows because it's a different kind of graph. And that is important to note as well. So be precise when there are arrows and when there are not. Otherwise, it is incorrect. Okay. Next line that we're going to graph, you have a couple options how to graph it. This was in, remember that form that we didn't work with too much? Standard form. Yes, standard form. So you have a couple options. You could put it in y equals mx plus b form and plot it that way. Or let me show you a little quick way when something's in standard form, how to graph it. I'm going to find the x and y intercepts. Oh, that x looks so ugly. I don't like it. Okay. To get the x-intercept, you substitute in 0 for y. So we would have 3x minus 0 equals -9. So 3x is negative 9. X is negative 3. And that's a point. Negative 3 is x. I plugged in 0 for y. So you could plot that. Negative 3, 0. Here's x, here's y. And then you can get the y-intercept. To get the y-intercept, you plug in 0 for x. So you'd have 3 times 0 minus y is negative 9. So negative y is negative 9, y is 9. But this is an ordered pair, right? 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those are our 2 points. Could I have been more off? What is going on with me right now? There, oh wow, what a comeback. Okay, and we're putting arrows. If you hated that, don't worry. I got another way for you. Or you go, I love y equals mx plus b. Y equals mx plus b, always and forever. So then, get y by itself. Negative y equals negative 3x minus 9. So y equals 3x plus 9. There's my b, there's my y-intercept, 0, 9. That would be where you start. And then your slope is 3. 3 over 1. So from there you can go up 3, run 1, which might be a little hard. Another thing you can do is you can make both of them negative, right? If you're running out of space, because the 2 negatives would cancel. So from here you could go down 1, 2, 3, and run 1 in the negative direction, see? Down 3, 1 to the left. So you have options if you're running out of space over here. Okay, but the intercepts can be a nice way to graph as well, up to you. So that concludes the lesson. Coming up next, we're going to get into supply and demand, exciting stuff. Give the video a thumbs up, subscribe if you haven't already. And like I said, if you need more algebra review, then hop over to the intermediate algebra video lectures playlist. More in-depth stuff there. Okay, I'll be back sooner than later. Bye.